Example 4, class of 30 students. So choir band. 7 are in the choir, but I can't immediately put a 7 there because it might be 7-0 or 7-5-2. But 2 are in the choir and the band, so that's great. That means I could put a 2 there, which means I need to put whatever it takes there to make 7 in the C circle. So that's 5. 5 are in the band, so if there's 2 there needs to be 3 there. Currently the numbers add up to 10, so that means there needs to be 20 outside. So that's part A. Part B. What's the probability that a student is not in the band? 20 out of 30. What's the probability that a student is not in the choir? Oh, wait on. Sorry, I misread that. Part B is, what's the probability a student is not in the band? Who's not in the band? Everyone outside the B circle. 25 out of 30. Part C, what's the probability they're not in the choir nor in the band? So that's 20 out of 30. And part D, given that a student is in the band, so it's not out of 30 anymore, it's just out of 5. What's the probability that they're also in the choir? So how many of the 5 that are in the B circle are also in the C circle? That's 2, so that's 2/5. Just check that's the correct answer. Yeah, it is 2/5. Okay, question number... Example number 5. Vet surveys 100 of her clients. So this is all about dogs, cats and fish. And I'm not sure whether there are going to be any people who don't own any. It'd seem odd if they're at the vets but don't own any, but on the other hand there's more than just dogs, cats and fish. So this is my basic look for that, and in fact 7 own dogs, cats and tropical fish, so I can put that, so let's call this dogs, cats, fish. Let's put 7 in there. Now let's build up from the most specific, which is that, to the most general. So 11 own dogs and tropical fish. So that needs to be a 4, so that's 7 and the 4 add to 11. 10 own cats and tropical fish. So in the intersection of the C circle and the F circle there needs to be 10, so if that's 7 taken up, that's 3 left. And 15 own dogs and cats. So that needs to be an 8, so that the 8 and the 7 combine add to 15. 25 own dogs, so we've currently got 19, so that's a 6. How many own cats? 53 own cats. So that's 15, 18. I think that needs to be 35, so it adds up to 53. And finally the fish is 40. So that's currently 14, so that's got to be 26. There's no overlap between any of these numbers anymore, so if I add them all up, 6 plus 8 plus 35 plus 7 plus 3 plus 4 plus 26, that's 89, so there must be 11 outside. So I was right, there are some people who don't own any of those particular animals. So that's the Venn diagram. What's the probability that somebody owns a dog only? So it's just this. So in other words, the ones in the D circle that aren't in any other circles, so that's 6 over 100 for part A. Does not own tropical fish. Who owns tropical fish? These ones. Who doesn't? This, and this. In fact, we have the total figure for tropical fish. It's 40. So for not tropical fish has to be 60. That's the question. That's for B. So that's for C. Does not own dogs, cats, or tropical fish. So that's the 11 out of 100. And then finally, given that a client's own fish and cats, so it's now just out of 10. What's the probability they do not own a dog? So of these 10, who doesn't own a dog? Those, that's 3 out of 10. I'll just check that those are right. Hope they are. 3 out of 10. Yep, so that's great. So that was example number 5. And now question number 2. 25 students in a certain tutor group at Phillips College. 16 students in the tutor group study German. 14 study French, and 6 students studying both French and German. So I think this is going to be a classic overlap one. 6 in the middle of the French and the German. It says 16 study German. If there's 6 there, then there has to be 10 there, so it adds up to 16. 14 study French. 6 there, there's got to be 8 there, so it adds up to 14. There's no overlap between these numbers because they're drawn in separate little areas, enclosed areas of the diagram. Venn diagram is designed like that. So these currently add up to 24. So is that right? There's only one student who doesn't do any. Yeah, I think that was always going to be the case, given the large numbers that study those. So, what's the probability somebody study French? 14 out of 25. What's the probability somebody studies French and German? 6 out of 25. Just this overlap section. Question C. Studies French but not German. So who's in the French circle but not in the German circle? So that's 8 out of 25. Does not study French or German. That's 1 out of 25. And finally, part E. Given that a student studies French, so just this circle now, so it's now not out of 25, it's just out of 14. What's the probability that they also study German? So in other words, of those 14 in the F circle, how many are also in the G circle? That's 6. That's 6 over 14. Number 3, on the firing range. And obviously a probability for firing range is not like counting things. It's not like you've got 5 students or 5 balls or whatever. But I'm in a second when I get these decimal probabilities, I'm going to imagine that they are. Just so I can get the diagram going. So on a firing range, a rifleman has 2 attempts to hit a target. The probability of hitting the target with the first shot, could use a tree for this by the way because it's about 2 things happening. Probability of hitting the target with the first shot is 0.2. So let's say he takes 10 shots. There'll be 2 in that circle. There'll be 3 for the circle of the second shot, and there'll be 1 in both. So that's got to be a 1, so that adds up to 2. That's got to be 2, so that's adding up to 3. And if there's 10 overall, there's got to be 6 outside. So now we're now good to go. So I'm just imagining 10 shots. Now you don't have to do that. You can write 0.1, 0.1, 0.2, 0.6. That's also good. I'm just keeping it concrete to be more friendly on my brain. So anyway, we're good to go now. What's the probability of missing the target with both shots? It's now out of 1, by the way, so it's 0.6 out of 1, which is obviously 0.6. Hitting the target with the first shot and missing with the second, so that's the first. So what's the probability that you're in the first circle but you're not in the second? So that's 0.1 out of 1, so it's 0.1 for B. Part C, given that the first shot hits, so we're in this circle, so it's now out of 0.2. What's the probability that the second shot hits 2? So of these ones, 0.2 is worth. What's the probability you're also in this circle? It's 0.1. So that probability is a half. So that's the answer for question 3. Just check that's right. Yeah, it is. Okay. Question number 4. Of all the households in the UK, 40%, so I'm going to make this out of 100, 40% have a plasma TV. Remember, the basic look is this, though of course there are other variations. You can have one circle entirely within the other, or you can have the circles completely disjoint from each other, is the technical term. So I'm just going to assume it's like that until it fails to work out with the numbers. So I'm going to put 40 in here, and I'm going to put 50 in here, and there's 25 who have both. So it's 40 in here, that's got to be 15. If there's 50 over here, that's got to be 25 as well, so these add up to 50 and those add up to 40. Currently those add up to 65, so that's got to be 35, so we're now good to go. Find the probability that a household chosen at random has either a plasma TV or a laptop computer, but not both. So what's in the P circle but not in the in the C circle for computer? Those 15. What's in the C circle but not in the P circle? Those 25, so it's 40 out of 100. Next question, find the probability that given that a house has a plasma TV, so we're now in this circle, so it's not out of 100 anymore, it's now out of 40. It also has a laptop computer, so it's 25 out of 40. Question number 5. 125 diners in a restaurant who were surveyed to find out if they'd ordered garlic. It might not be this, but for 3 things, this is what I start with. Especially when it says that there's some people who've had all 3, so that's my 15 there. So we got garlic, we got beer and cheesecake. So if there's 15 that all have 3 and 43 have garlic bread, so that's got to be 28, so it adds up to 40. No, wait on. Sorry, I've forgotten the rule that you start with the most specific and move out to the most general. So I'm going to do beer and cheese, 20. So if that's 15, that's got to be 5. 26 had bread and cheese. Sorry. Oh, I'm having a shocker. 15 of all 3, 26 have bread and cheesecake, so it's got to be 11, so they add up to 26. Garlic bread and cheesecake is... So beer and cheesecake is 20, so sorry, that's 5. Garlic and cheesecake is 26, that's 11. Bread and garlic is 25, so that's 10. Now, 43 have garlic bread. Currently there's 36 in garlic bread. So we're going to build that up to 43, so that's 7. What about beer? The total has to be 40. Currently the total is 30, so that's 10. And finally for cheesecake, 44. Currently it adds to 31, so it's got to be 13. These now add up in total. There's no overlap between these, so we can add them up straight out without worrying about overlap. So I'm just typing all the numbers that I see. So that's 71, so that's to be 29 outside. Remember, this was... Oh, no, I'm sorry, I assumed it was 100. So that needs to be 29 plus 25, which is 54. Outside, and now we're good to go. So, what's the probability they have all 3? 15 out of 100 and 25. Beer but not cheesecake and not garlic bread. So what's in the beer circle? But is not in the in any of the other circles, that's 10. So 10 out of 125. Garlic bread and beer, but not cheesecake. So garlic bread, beer, so it's those, but not cheesecake, so that's the 10. It's 10 out of 125 for part C. None of the items is 54, we already worked that out. Given that a diner ordered garlic bread, so we're now just out of these ones here. The garlic bread total is 43. It's now out of 43. This is part E. What's the probability that they didn't order cheesecake? One of the ones that in the garlic bread, the 43, who didn't order cheesecake, it's these ones outside the C circle, so that's 17 out of 43. Just check that that's right for question 5. There it is. Okay, so there are enough solutions for the Venn diagram exercise. The other ones are pretty much the same as those.